Now the elimination reaction is that in which we will see that the smaller molecules, or you can say a group of atoms, are being removed from the reactant. So just look at the board, that how it occurs. Suppose I have this compound. The name for this compound is, we know that is ethanol, CH3CH2OH. Now I will tell you that how it undergoes the elimination. The elimination generally occur in the presence of alcoholic KOH. It is the best suited reagent, we can say that, which can bring about the elimination. Now we can see that on this carbon there is an OH group, and from this carbon we can also remove one atom, that is the hydrogen, right. So that means if we'll you can say react in the presence of alcoholic KOH, then what happens, that H and OH is being removed, that means it will form CH2, and it will form again CH2, and as they have lost their bond, so they will form a double bond between them, and as a result there is an elimination of the smaller molecule, that is the water. Likewise, we will do another example. What is it? It is CH3CH2Cl, that means it is ethyl chloride, or you can say it's chloroethane, right. So now again I react it in the presence of alcoholic KOH, and as we can see that we can actually remove the two groups, one let's say Cl, another again the H1. So that means we can have the HCl removed. So again we will get the compound CH2, again single bond CH2. Now as they have lost their two bonds, so they will be forming two bonds, double bond between them, and there will be a loss of a smaller molecule, that is HCl. So this kind of elimination we can see that. Now what happened is that actually we have three types of eliminations. We have three types of eliminations. It can be alpha elimination, it can be beta elimination, it can be gamma elimination. Now what is the difference that lies between them? In alpha elimination, what is there, that first of all I would like to tell you that what is alpha, what is the alpha position actually. Alpha position is that carbon to which any substituent is being attached. So let's say OH is attached to this place, so this is my alpha carbon, and the carbon which is next to this carbon is beta carbon, and the carbon which is next to it is regarded as gamma. Like in this case there is no carbon atom, but if you have in case that is the gamma. Let's see in some other example. Let's say here it is an alpha halogen, again it's beta and it is gamma. So that means alpha is the one to which the halogen is being attached, or any other substituent. Next to it is the beta, and next to beta is the gamma. So now coming on to the types of elimination reactions. So alpha elimination is that in which the loss of two atoms occur from the same carbon. That means the same carbon, which carbon? The alpha carbon. From that only we are removing the two groups, or you can say two atoms. Beta one is that in which the one atom is being lost by the alpha carbon and one atom is taken away from the beta carbon. I repeat, one atom we have removed from the alpha position and other we have removed from the beta. If it is like that, then it is called as beta elimination. Like in both the examples, it was beta elimination because I was taking one substituent from alpha and one atom from the beta position. So that means it is a kind of beta elimination. Gamma is that when the loss of two atoms occur from alpha and gamma positions. As you can see that here this is my alpha and this is my gamma. So that means I can remove one atom from the alpha and one atom from the gamma. So if I remove this and this, then that means it is a kind of gamma elimination. I repeat, alpha elimination when you remove both the groups from the same carbon, right? And when you remove one group from the one carbon, that is the alpha, and the other group from the beta, then it is beta elimination. And when you remove one atom from the alpha position and one from the gamma, then it is a gamma kind of elimination. So I have few examples. Let's check out that what kind of elimination we can actually have. So this is this compound. So in this is my alpha and this is my obviously a beta carbon. But if I want to show a kind of alpha elimination through it, that means I need to remove two atoms from the same carbon atom. So that means suppose I will remove this Cl and I will remove this H. So when I will remove that, so what we will get is, we will get something like that. That means two bond will be free now because it has already removed one HCl molecule, and this removal, that is the H and Cl, occur from the alpha carbon itself. So that it is a kind of alpha elimination. It can be beta also. Look at this example. This is my alpha, this is my beta, and this is my gamma, right? If I wish to show a beta kind of elimination, then I'll be taking, I'll just write the this thing again. It's like that. It's something like that. So when it is undergoing a beta elimination, obviously we need to react in the presence of alcoholic KOH, same this place also. So it will remove one atom from the alpha position and one atom from the beta. So that means it will form CH3, CH2, C bond will be double because they have lost their bonds, and it will be again H2, and this H will remain here. So we will get this kind of compound, that is the butene. Likewise, let us see for this. As you can see, there is a halogen present at alpha position and halogen present at the gamma position. So what happens? We remove this alpha and gamma, and it occurs in the presence of zinc in this case. So what happens when we remove it? So that means this bromine and bromine gets removed, one from the alpha position and one from the gamma position. And as a result, what we get? We get a cyclic compound. So this kind of elimination actually you can see. So you just need to remember that elimination is something in which we are going to remove a molecule, and if the atoms, like that molecule is formed obviously as a result of the combination of those atoms, right. If two atoms are removed from the same carbon, that is the alpha carbon, then it is a kind of alpha elimination, occurs in presence of alcoholic KOH. It is the best suited reagent actually. And if the removal of one atom occur from the alpha carbon and the atom is being removed from the beta position, then it is a kind of beta elimination. Again, it occurs best in the presence of alcoholic KOH. And gamma one is that in which we remove one atom from the the alpha carbon and the other atom from the gamma position, right. So, and it will lead to the formation of cyclic compound of every time, and it occurs in the presence of zinc. So if we consider alpha and beta, so they mostly occur in alcoholic KOH. It is the best suited reagent, and when you are carrying out the gamma elimination, it occurs best in the presence of zinc. And mostly like what you come across many kind of eliminations. So out of that, which is the basic or the common elimination? That is the beta elimination, which I told you when I was discussing this examples. That is one atom from the alpha position, other atom from the beta position. This is what we see actually. And you know that if the elimination can occur from either side, then we actually follow that rules. You know that you are almost familiar with the Markovnich's rule, you are familiar with the CHEM rule, you know that, right. So if the elimination can occur from both the methods, we can actually use the CHEM rule, in which we will be using that compound which is maximum alkylated, right. And after losing this, they will just retain their valency by forming the double bond, right. You need to know that also. So this is what is the elimination reaction. So now we will be discussing about the substitution reaction. Just look at the board.